Hello everyone, welcome back to this channel. In this video, we are going to continue our discussion on Cambridge International AS and A-Level Mathematics, Paper 1, Pure Mathematics 1. So this will be the last number on this paper, question number 11. Now in this question, we are given the following diagram, and this diagram shows the curve with equation as the following. For x is greater than 0. The curve crosses the x-axis at points A and B and has a minimum point M here. For the first question, find the exact coordinates of M. If you take a look here, M is the minimum point. So if you see the word minimum, that means this question is related to derivative. Okay, so first of all, you need to take the derivative of this equation. Okay, so we have y equals 2x to the power of negative 2 over 3 minus 3x to the negative 1/3 plus 1, where x is greater than 0. Now let's take the derivative. Dy dx is equal to, for this one, 2 times negative 2 over 3 times x to the negative 2 over 3 minus 1, which is 5 over 3, and then negative 3 times negative 1 over 3, x to the power of negative 4 over 3, and then the derivative of 1 is 0 because it's just a constant. Okay, simplify a little bit. This is equal to negative 4 over 3, x to the power of negative 5 over 3, and then this one will be plus x to the power of negative 4 over 3. Okay, now we have minimum point M. That means you need to set the first derivative to be 0 and then find the value of x. Okay, so we make dy dx equals 0. That means negative 4 over 3 x to the negative 5 over 3 plus x to the power of negative 4 over 3 equals 0. Okay, you can factorize this expression. So we have x to the power of negative 4 over 3. Open the bracket. Inside the bracket, we have negative 4 over 3 x to the power of negative 1 over 3, and then plus 1 is equal to 0. So from this factorization, we know that x to the power of negative 4 over 3 is equal to 0, or the second factor is equal to 0. Negative 4 over 3 x to the power of negative 1/3 plus 1 is equal to 0. From the first one, we get x must be equal to 0. For the second one, we know that 4 over 3 x to the power of negative 1 over 3 is equal to 1. Now, x to the power of negative 1 over 3 is equal to 3 over 4. And if you want to get x, that means you need to raise both sides with the power of negative 3, like this. So you get x on the left hand side. This is equal to 3 over 4 to the power of negative 3 is equal to 64 over 27. Okay, so we found that the x coordinate of point M is the following. Now in order to get the y coordinate of M, you just need to substitute this value into the equation of the curve. Okay, so y will be equal to, okay, the equation is like this. 2 times x is 64 over 27 to the power of negative 2 over 3, and then minus 3 times 64 over 27 to the power of negative 1/3, and then plus 1. Work this out using your calculator, and you will get y is equal to negative 1 over 8. Okay, negative 1 over 8. And for this value of x is equals to 0, we don't need to use this because we know that x must be greater than 0. So this one is not possible. Okay, now we get the coordinates of M are x comma y, so 64 over 27, comma negative 1 over 8. That's the answer for question number 11A. Now for question B, we need to find the area of the region bounded by the curve and the line segment AB. Okay, so we need to find out the area of the following region, starting from x equals this one until x equals this one. That means we need to find out the coordinates of point A and B first before we do this question. Why do we need to find A and B? Because those points will be the limit of the integration. And since we talk about the area under the region, that means we talk about integral. Okay, now we find the coordinates of A and B, starting with the equation of the curve, which is 2x to the power of negative 2 over 3 minus 3x to the power of negative 1 over 3 plus 1. Since we would like to get the x-intercepts of the curve, we must set y equals 0. So we make this one is equal to 0. And then you can do the following. Let's say let p equals x to the power of negative 1/3. So our equation becomes 2p squared minus 3p plus 1 is equal to 0. This can be factorized as 2p minus 1 times p minus 1 is equal to 0. So we get p is equal to 1 over 2 or p is equal to 1. And what is p? P is x to the power of negative 1/3. This is equal to 1 over 2. And this one is also equal to 1 over, this one is equal to 1. Now that means x is equal to 8. And from this one, x is equal to 1. So we got the coordinates of A and B. That means A is here. So the x value is smaller than the x value of B. That means x is, A is 1, 0 and B is 8, 0. Okay, now we can find the area using integration. The area is equal to, notice that the area is actually below the x-axis. So if the area is below the x-axis, you need to put negative sign in front of the integral in order to make the result to be positive. So negative integral going from 1 to 8 of the function, which is 2x to the power of negative 2 over 3 minus 3x to the power of negative 1/3 plus 1 and then dx. Okay, so now let's do the integration. Okay, we can distribute the negative first. So integral from 1 to 8 of negative 2x to the power of negative 2 over 3 plus 3x to the power of negative 1 over 3 minus 1 dx. Now we integrate one by one. If you integrate the first term, you will get negative 6x to the power of 1/3. Integrate the second term, you will get 9 over 2x to the power of 2 over 3. And then integrate the third term, you will get negative x. And this is from 1 to 8. Now you substitute the limit of integrations starting from the upper limit first. So negative 6 times 8 to the power of 1/3 plus 9 over 2 times 8 to the power of 2 over 3. And then minus 8. And then minus. Now you do the same thing but now with x equals 1, the lower limit. So this is negative 6 times 1 like this, and then 9/2, and then minus 1. So work this out. The first one here, you will get negative 2, and then minus. For the second one here, you will get negative 5/2. So this is equal to negative 2 plus 5/2. That means the area is equal to 1/2. Okay, so that's about the solution of question number 11, which is the last question on paper 1, Pure Mathematics 1. Hopefully all the videos that I made are useful for all of you. And thank you for your kind attention. I wish you best of luck for your A-level exam preparation. Thank you.